Good morning, everybody. I'm David Lutz from Leica Geosystems. I represent the Geomatics division of Leica. I am here to talk to you about our latest innovation and our softwares and how they all integrate into the 3D modeling process that is truly unique. This is a one-of-a-kind instrument. No one in the world has it. We've been able to combine our high-end total station with our high-end scanning capabilities and put it all into one machine and making it much more affordable. What I'm going to show you today is how Leica has taken 3D mapping, which is a big part of BIM, and using Revit and all the modeling that everything is going to be built on in the future. I mean, all agencies, government agencies, and state agencies, federal government, state agencies, local governments are starting to require the BIM process because it's a much more efficient way to build. One thing I see in BIM with my experience in land surveying is when things don't go right because they weren't well thought out and weren't engineered correctly or designed by an architect correct, there becomes a liability issue because overages become a huge part of a public project. And nobody wants to have overages and back charges. So I think the BIM process is amazing in helping with that. This machine is a traditional total station. It will measure angles and distances just like a regular total station that any surveyor could use. It has a scanner that you'll see when the data I sent out to Joe that took about 13 minutes total to collect. You'll see images. It does imaging, scanning. It goes to the field every day, unlike what Stuart was talking about. Traditionally, a surveyor has a total station, they have a GPS, and then they have the scanner. This does everything in one shot. It runs all of that data, brings it all together into one job file, one string of data into an XML format, and goes into Civil 3D, AutoCAD, Autodesk products with like 2 clicks of a mouse. I think the total process by the time you set up your project is maybe after you've set up your project and your templates is like 6 mouse clicks and the data's in. So we're streamlining getting 3-dimensional data out of the instrument from the field to the finished product, and then the drafters take over from there. Traditionally it used to be get the data out, put it in special, very expensive software, take that data, the imaging and the scanning data, mesh it together using a special software that Leica created called CloudWorks, and there's some other point cloud data management softwares that do that, and then take it into your Revit or take it into Civil 3D. We've simplified that process. We're doing it all with one instrument, whether it be this or our scanner, and we're taking that string of data along with all that digital information and putting it straight into your Autodesk products or ListCAD products or microsurvey products. Those 3 are all of our partners right now. We've partnered up with Autodesk. So the development just started. Joe has about a half an hour of practice on this. So we're going to see how well Joe does. From what I saw the other day, it's no problem. It's that easy to run because you're running in your known environment. This instrument crosses over so many different platforms now. It could be used every day in the field for surveying, whether it's boundary surveying, construction surveying, layout. It can be used by architects to do, I just gathered data of this room, 700ths by 700ths of a foot, so a little over 1/2 inch by 1/2 inch data, a point cloud that's going to have everything, along with imaging that they are actually overlaid and perfectly related to one another. There is no stretching factor, any magic going on in the background. It's all scaled properly. This instrument, like Joe was saying, is from field to finish. Design, after the design, we go to layout. Electrical contractors can set up the instrument, do their layout. Any contractor can literally take this instrument and go do their layout, and then after the project is complete, they could set it up again and do the same process that they did the first time. Let's get an as-built of all the work that they did, so there's a way to check your work, a way to CYA, you know, and just a way to help you have more QC checks all the way around. So it's an amazing instrument. Some architectural firms are actually looking into this instrument. Engineering firms certainly are. But this whole concept of 3D data collection and the BIM process, it's a beautiful thing, and Leica Geosystems is dead involved with it with Autodesk. And Holman's, you're pretty lucky because they can train you how to use all this great technology from the field to the finished product. So I have gone ahead and completed a scan with imaging, and I'm simply going to export it out of here and hand it over to Joe, and we'll go ahead and show you what kind of product this 3D product this machine will give you.
I've actually seen this live, what he was just talking about, the data and how this data goes from the field to the office to the field. I was with a guy who was building a golf course. This thing had 500,000 contours, and they were using machine control. The contractor called me, so I got out there, and they had changed one of the holes, which significantly changed the design, and it went from the designer in Iowa to the golf course in Las Vegas to the machine, the CAD file, and all those changes, and it took 2 minutes. and that's like weeks. That process would literally take weeks before. But because of this technology and how it's all connected and the partnership with AutoCAD, it was like 3 minutes, 2 minutes. There you go back to work. And that's that's where these instruments, I see, it really, the advantage is that now the projects are live. The delay in concept to design to build is how fast is your internet.
All right, so XML, you guys have probably heard of it. So XML file format is what they use to capture all of the data that he was talking about, points, lines, images, scan data. And so we're taking that whole job, that whole set of information that he just captured in the last 10-15 minutes, all bundled up, and we're bringing it over so that we can take a look at it in the software. It's kind of the spread, just to give you an idea of, and here's each of those individual pictures. So that's y'all.
That's just point data, not even a photo.
Find my way to-
So I took the workflow is that I define an area that I want to scan. So I define this room, this part of the room, so I could get some color. The first step in the process is the camera takes a photo. In this case, it takes 40 photos, 40 high-def photos, and stitches them together to make one panoramic. So you'll end up with one panoramic, which he already showed you, the picture of you guys, and then 40 individual photos that you can zoom in on and look at. And then after that process is done, then it takes a scan. And what you're seeing here is the actual scan. It's just points.
Autodesk has a lot of products
Your job, buddy.
these days that support point cloud data. They have Recap, which is in all the new suites. Navisworks will bring in a point cloud from a construction standpoint. That can be useful in comparing the digital model to what has actually been installed. Revit can bring in a point cloud now. Civil 3D can connect in a point cloud. So I'm going to take this out. The one thing we're going to be showing later, InfraWorks can also now bring in a point cloud. So I'm going to save this out as a particular point cloud file so that I can use this maybe a little bit later. So one workflow might be, if you want to bring the cloud into Revit, you have to take it through something like Infinity first to export it properly so that you can attach it later to a Revit project. So we did that, and that's sort of chugging along here in the background. It's exporting a lot of data. So another potential workflow is if you have a Civil 3D, for instance, and you're used to working with points, with this MultiWorks software that they just introduced, you can bring the cloud directly in to Civil 3D. So you get an entire ribbon full of tools. I can point back at that same sort of XML file that contains all the project data. I can choose what units I want to work in, and then it's going to bring, very similar to what we saw in Infinity, but right into my AutoCAD environment. And you can see up here on the ribbon there are things like you can orientate yourself to various planes, so you can lock into that cloud geometry and start to create walls and surfaces and other kinds of things that would be useful to start building your design. So shortly here we'll have some points to take a look at. There it is. And then you can look at it in a perspective view. You can change the visibility settings. I think they're right in here. Color from scanner. So that looks like the photo. Intensity mapping. That's the red, yellow, green. So based on the reflectivity of the material that you're shooting. And then you can change to true color. There's some other options inside of there. Let's see, appearance. You can change it to a single particular color if you want. You can do shades of gray. You can do shade, all sorts of different things to manipulate the point data.
Literally, he's only played with this for half an hour. Because it's in his typical environment, he's very familiar with the commands. So I took a photo of here. In here, had I taken what's called a reflectorless shot, say on the joint between that wall and the ceiling, and that column that's behind that drywall there, if I need that for a critical design point, I literally look through here, point to that corner within a millimeter, and shoot that point, and store that as a XYZ ASCII point. These are objects that you can actually identify coordinates on. These are only objects. They're the point cloud. If I shoot that reflectorlessly and store an XYZ with a code, that becomes an ASCII point, an actual data point. And then when he brings that in, he'll see that critical design point, so he can zoom right in on it. Is that what you're asking?
Yeah, in that image.
And it'll have a crosshair on it.
Very good.
And I could color that crosshair.
Yeah.
I could color it red, so if I got a white surface, I wouldn't want a white crosshair. I could change the coloring here before I shoot it. And that's what I would do as a surveyor to help the designer. I would shoot the top corner of the building, this ceiling, and maybe a point on the floor, and another point on the floor, so he has a plane, so it makes his drafting job that much easier. That point with the crosshair will show up on the image, and it will also show up in his data set. And I could connect the lines. If I shot that corner, using coding, I can say draw a line from here to here. Now it's already drawn for him. So now he knows his reference plane, and he had a toolbar in his Multiworks where it said floor wall plane. He literally just clicks on that and sets a floor wall plane, and then everything will be all of his line work will be perpendicular to the plane that he actually sets.
And you can also store an image of that critical point and store it to that point, right? So you can store that image and tie it to that point. And you can write a note on that image too, if that's not enough.
Yeah.
You can write a note on the screen with an
So,
arrow.
so you're concerned,
And that all comes across.
architect, I would like shoot that and say, architect design point number 1, or critical point number 1, right on the photo, right here
Right
in
on
the
the screen.
field, I write it with a pen, right on the image, and that image gets stored with my field note right on it.
And tie to the
Critical
point.
tie point 1, architect, so you know what it is.
So this is another product, this is another potential workflow. So we took that export out of Infinity, which happened to be about 8 megabytes or so, and we brought it into Recap. And so Recap has a couple different technologies. It'll use laser scan data, so it'll take a point cloud like this and allow you to visualize it, allow you to combine scans together, this registration unify process that we were just speaking of. And I was kind of cruising through creating this project quickly, so it's in meters, but you can see that I was able to measure, and you can measure, so again, you can measure a couple points on a particular feature, and you can collect all that data. So all the same capabilities, selecting a plane, windowing to grab just a certain selection of information. This is a thematic scheme for elevation, so you can see it decided to take these different colors and maybe do it a meter at a time. So all those ground floor, they're right there in the red, and so on. So
we gotta go.
You gotta hit the road, but
That's okay.
We gotta go to Carson's.
you can see the different capabilities inside of this software as well. Again, density of the points, do some annotation, and then again, I can take something like this into, and there's all your basic navigation tools, to pan and zoom in on the project and things like that. So in these areas where the scan starts to not give us all the data that we need, it's just a matter of using a secondary scan location. So we set up there, then we maybe set up over there, we catch the backside of the other that we didn't see before, and then stitched together, we've got sort of a complete picture. So there it is in Revit. So now you could start to draw walls where the actual walls are, get your doors where the actual doors